Derivative and integral of Laplace transform. Last session we have discussed about the integration and the differentiation of the Laplace transform. Now, first of all, what is the Laplace transform derivatives? If Laplace of f of t equal to f of s, then Laplace of f dash t we get as f of 0 minus f of 0. And Laplace of f double dash t s square f of 0 minus f minus s f of 0 minus f dash 0. In general, Laplace of f of n raised to n t s raised to n f of s minus s raised to n minus 1 f of 0 s minus s raised to n minus 2 f dash 0 minus f of raised to n minus 1 0. Proof. Taking definition of the Laplace transform, Laplace of f dash t equal to 0 to infinite e raised to minus st f dash t. Integrating by parts, we take e raised to minus st f of t 0 to infinite minus 0 to infinity minus s e raised to minus st f of t dt. Putting a limit in first integral, we get minus f of 0, and for this case s 0 to infinite e raised to minus st, and this is the definition of Laplace transform. So we write as f of 0 minus f of 0. Similarly, for the Laplace of f double dash t equal to minus f dash 0 plus s Laplace of f dash t equal to minus f dash 0 plus s Laplace of s f of s minus f of 0. So, we conclude s square f of s minus s f of 0 minus f dash 0. In general, we getting this polynomial form. Now, example of the derivative. Find Laplace of f of t and Laplace of f dash t for this function. First, we are finding Laplace of f of t. What is the Laplace of f of t? E raised to minus 5t sin t. Okay. Step 1. Laplace of sin t 1 upon s square plus 1. But due to in function multiplication is e raised to minus 5t, we are applying first shift theorem. So this is your answer of the f of s. So we find first Laplace of f of t. Now we have to find Laplace of f dash t. What is Laplace of f dash t? It is s f of s minus f of 0. S f of s, that means s plus 5 whole square plus 1. F of 0, we are putting sin t, sin 0, so it is 0. Answer is s upon s plus 5 whole square plus 1. Okay. Next example. Find Laplace of f dash t where f of t equal to 3 and 0 and limit of t is for the 3, 0 to t, 0 to 5 and t greater than 5. First of all, we have to find Laplace of f of t, and that is we have to find using definition of Laplace transform. E raised to minus st f of t dt 0 to 5, 3 e raised to minus st dt So it is 3 e raised to minus st upon minus s, 0 to 5. So it is e raised to minus 5s upon minus s plus 1 upon s 3 multiplication. So we get 3 by s, 1 minus e raised to minus 5s. Now we have to find Laplace of f dash t. Formula is as f of s minus f of 0. For the s, 3 by s, 1 minus e raised to minus 5s. Now we are putting t0. If we are putting f of t equal to 0, so we get it is 0. Because t is less than or equal to 0 formation, it's give our answer as a 3. So 3, 1 minus e raised to minus 5s minus 1. Answer is minus 3e minus 5s. Okay. Next, Laplace transform of integrals. If Laplace of f of t equal to f of s, then Laplace of integration 0 to t f of t is f of s by s. Proof of this theorem: integration 0 to t f of t dt. We are taking this integral directly as a f of t formation, 0 to infinite e raised to minus st. This is a definition of the Laplace transform. And integrating by parts, we get 0 to infinite 1 by s e raised to minus st f of t dt. So answer is f of s by s. Now, next example is integration 0 to t e raised to t sin t by t dt. Here we have to compulsory follow the order of the formula. First, we have 0 to t e raised to t sin t by t, okay, dt. Now, step 1. First is original function. What is original function? Laplace of f of t, Laplace of sin t. What is the Laplace of sin t? It is 1 upon s square plus 1. Next is sin t by t. Sin t by t. So, division by t, we are integrate s to infinity 1 upon s square plus 1 ds. So we get Laplace of sin t by t. It is your step 2. Tan inverse s to infinite. So answer is cot inverse s. Step 3. Find Laplace of e raised to t sin t by t. So cot inverse s to s minus 1. So answer is cot inverse s minus 1. Now, last step, Laplace of integral 0 to t e raised to t sin t by t dt. So answer is cot inverse s minus 1 upon s. Due to integral, we are divided by s. So this is your answer. Revise this. Laplace transform for integration 0 to t e raised to t sin t by t dt. So first we have to find Laplace of sin t, then division by t rule, then first shifting theorem, and then applying integral rule. So your answer is cot inverse s minus 1 by s. Next example, find Laplace transform of integration 0 to t sin a t dt. Step 1, find Laplace of sin a t. It is a upon s square plus a square. Due to two-time integral, we are dividing 2 times s square, and this is your answer.